Look up at the sky, and you'll see our sun, the brilliant star at the very heart of our solar system, shining with a light that has guided life on Earth for billions of years. The sun is the source of all light and warmth on Earth, making life possible and shaping our planet's climate and weather. Its energy powers the winds, the oceans, and even the food we eat, through the process of photosynthesis. Without the sun, our planet would be a frozen, lifeless rock drifting through the cold emptiness of space, unable to support any form of life as we know it. The sun is about 4.6 billion years old and is considered a stable middle-aged star. Scientists study it closely to understand not just our own star, but the life cycles of stars throughout the universe. Its size is truly staggering. You could fit over 1 million Earths inside the sun, and its immense energy output dwarfs anything we can imagine. The sun's powerful gravity keeps all the planets, asteroids, and comets in orbit, making up more than 99% of the solar system's total mass and holding everything together in a delicate cosmic dance. But like everything in the universe, the sun has a life cycle. It was born from a swirling cloud of gas and dust. It's now living through its long, stable years, shining steadily and providing the energy that sustains our world. But nothing lasts forever, and one day, even the sun will reach the end of its life. Its end won't be sudden, but a slow, dramatic transformation over billions of years as it expands and changes, eventually becoming something entirely new. Let's journey through time together to discover how the sun was born, how it lives, ages, and what will happen when it finally dies. This is the incredible story of our solar system's past, present, and far future, a story written in the light of the sun. What makes the sun shine? It's a question that has fascinated humanity for centuries, inspiring myths, legends, and scientific curiosity alike. Deep in its core, nuclear fusion fuses hydrogen atoms into helium, releasing immense energy. This process is the very engine that powers our sun, making it a brilliant beacon in our sky. The sun's core is unimaginably hot, about 15 million degrees Kelvin. At these temperatures, matter exists as plasma, a state so energetic that atomic nuclei can collide and fuse. Every second, the sun converts millions of tons of mass into energy, which we see as sunlight. This energy radiates outward, bathing our planet in warmth and light. Gravity tries to crush the sun, but the energy from fusion pushes outward, keeping the star stable. This delicate balance is what allows the sun to shine steadily for billions of years. Photons created in the core take thousands of years to reach the surface, bouncing endlessly through dense plasma, then just 8 minutes to travel the vast distance to Earth. This process is the most efficient energy source in the universe, powering every star we see. Without fusion, the cosmos would be a much darker place. The sun is slowly using up its hydrogen fuel, and when it runs out, everything will change. Its life is a cosmic countdown, ticking away over billions of years. The story of the sun is the story of its fuel, how long it can keep burning before it transforms. Eventually, it will evolve, marking the end of an era for our solar system. Our star is a cosmic engine, but its fuel won't last forever. The sun's journey is a reminder of the ever-changing nature of the universe and our place within it. Right now the sun is in its main sequence, a long stable phase that's lasted 4.6 billion years and will continue for about 5 billion more. This stability has allowed life to thrive on Earth. With the sun's energy output remaining steady, the sun is in perfect balance. Gravity, pulling in, fusion, pushing out. Minor fluctuations like sunspots occur, but overall, the sun is reliable. Think of it as a car on cruise control, smoothly running with a full tank. But eventually, the sun will run low on hydrogen, and its calm phase will end. The end of the main sequence will bring dramatic changes to our solar system. In about 5 billion years, the sun's core will run out of hydrogen, breaking the delicate balance that's kept it stable for billions of years. This process is inevitable, a natural part of a star's life cycle, and marks the beginning of a dramatic transformation. As the core collapses and heats up, the sun's outer layers will balloon outward, expanding far beyond its current size. The sun will become a red giant, growing hundreds of times larger and brighter than it is today, dominating the sky in a way we can barely imagine. The sun will grow so large it could engulf Mercury and Venus, and possibly Earth itself. Our planet may be swallowed whole, or left teetering on the edge of destruction, scorched by the sun's immense heat. Even if Earth isn't swallowed, the intense heat will boil away the oceans, strip the atmosphere, and erase any trace of life. The once blue and vibrant world will become a scorched, lifeless wasteland, unrecognizable from the planet we know today. The sun's red giant phase is a natural part of its evolution, a fate shared by countless stars scattered across the galaxy. This transformation is not unique, but it is a powerful reminder of the cycles that govern the universe. A shell of hydrogen around the core will ignite, fueling the sun's expansion even further. This new burst of energy will drive the sun to its largest and most dramatic form. The sun will no longer nurture life, but become a bloated giant, consuming the worlds it once sustained. Its warmth, once life-giving, will now be a force of destruction, erasing the history of the inner solar system. This phase will be catastrophic for the inner solar system, as planets are scorched, atmospheres are lost, and orbits are forever changed by the sun's immense power. The sun's transformation is both spectacular and destructive, a cosmic event that will reshape everything in its reach. It is a breathtaking display of nature's power and inevitability. The red giant marks the beginning of the end for our solar system's familiar worlds, a final fiery chapter in the sun's long and remarkable story. The red giant phase is brief. The core heats up until helium fusion ignites in a dramatic helium flash. Helium fuses into carbon and oxygen, giving the sun a short second life. But the sun isn't massive enough to fuse carbon, so fusion soon stops. The core collapses again and the outer layers drift away, forming a glowing planetary nebula. This nebula enriches space with elements forged in the sun. At the center, the sun's core remains as a white dwarf, an Earth-sized, super-dense stellar remnant. A teaspoon of white dwarf material would weigh tons. The white dwarf glows with leftover heat, no longer producing energy. The sun's final act is to create a nebula and leave behind this dense, cooling ember. It won't become a black hole, just a small, fading relic of its former self. The white dwarf that was once our sun will slowly cool for trillions of years, shining only from residual heat. Over time, it will fade from white to red, then become a cold, dark black dwarf. No black dwarfs exist yet. The universe isn't old enough. The sun's story ends quietly. From a brilliant star to a cold, invisible remnant, this cosmic cycle reminds us that even stars aren't eternal. The sun's elements will help form new stars and planets, continuing the cycle of creation. In the end, even the brightest stars must say goodbye.